Hello, this will be our first lesson in Geometry 11. It's called Patterns in Inductive Reasoning. It's section 1.1. It's the first section of the first chapter. On this slide, we're going to use our past experience to make a prediction about what will happen in this situation. It is cloudy outside and it seems to be getting darker. You have not seen a weather forecast, but you decide to go indoors. Why? Think about that for a few seconds. Why did you decide to go inside? You look at the sky, it seems to be getting darker. You haven't seen a weather forecast, but you decided to go inside because you've pretty much seen this situation before. You've probably been caught in the rain before or a storm. So when these things happen, you're using your past experience to make a prediction for what is probably going to happen in the future. Now, you may ask yourself, what did that have to do with math? Well, really, it didn't have anything to do with math, but this term, inductive reasoning, is what you used, and that's what we're going to use in math a lot this year. Inductive reasoning is making a conclusion based on a pattern of examples or past events, just like you did in that little weather situation. Originally, mathematicians used inductive reasoning to develop geometry and other mathematical systems to solve problems in their everyday lives. And they did this hundreds of years ago. So this is not a new concept. Okay, so that first situation really didn't have anything to do with math, but these next few are. We're still going to use inductive reasoning. We're going to recognize a pattern. We're going to make a prediction. Okay, so we're going to use inductive reasoning to find the next three terms of the sequences. Probably not a bad idea to write this down or have these slides in front of you. In number one, we're looking at the sequence 33, 39, 45. Try to find a pattern. Try to find what comes next. We're looking for the next three terms. Take a few seconds. Okay, that first one was pretty simple. Hopefully you realize that each following term has increased by 6. So 33 to 39 was an increase of 6. 39 to 45 is an increase of 6. So your next three terms would be 45 plus 6, which is 51. 51 plus 6, which is 57. And 57 plus 6 will give you 63. Okay, so to answer the question, you need 51, 57, 63. But really the most important thing here is recognizing that pattern, increasing by 6 or adding 6. Adding is a mathematical operation. Okay, number two, same idea, a little bit different with the decimals. We know you don't like decimals, but they're numbers too. If you struggle with the whole decimal concept, maybe just think of it like money. A little easier that way. 1.25, 1.45, 1.65. What would the next three terms be? You can probably do that one in your head, but if you can't, it's okay to use a calculator or to use your phone to get the next three terms. Okay, again, most important thing, what is the pattern? Is it increasing? Is it decreasing? Is it going up by the same amount every time? Is it going down by the same amount every time? Those are the questions you need to ask yourself. Okay, the pattern here is we're increasing by 0.2. or 20 cents if you want to think about it like money. So our next three terms would be 1.85, 2.05, and 2.25. Okay, so both of those sequences, numbers 1 and 2, use the mathematical operation of addition. These ones are a little bit different. Same concept, but you should notice something different about number 3. We're going from 13 to 8 to 3. Find the pattern first. What would the next 3 terms be? Take a minute and think about it. Okay, hopefully you've recognized that we're subtracting this time. We're getting smaller each time, and we're getting smaller by the same amount. So we're subtracting 5 from each term. So you should do 3 minus 5, which ends up giving you a -2, which we haven't looked at negatives yet. Then do -2 minus 5, which will give you a -7. And -7 minus 5, which puts you at -12. Okay, so we introduced a new operation to use in our sequences, and that was subtraction. You're going to have another new one in number 4. So number 4, we're going from 1 to 3 to 9. Notice how we're increasing again. But are we increasing by the same amount? Okay, we are not increasing by the same amount. So most of the time, you should think of that as multiplication. 1 to 3, you can multiply by 3. 1 times 3 is 3. 3 times 3 gives you 9. So to get your next 3 terms, you should do 9 times 3, which is 27. We should all know that one. Now, at this point, you need 27 times 3, which you might not know off the top of your head. You can use your calculator. 27 times 3 is 81. Okay, now same thing here, 81 times 3, a little bit bigger. If you're using your calculator, you could just hit times 3 after the 81 is in your calculator. That'll give you 243. Okay, so our 3 answers here should be 27, 81, 243. When your numbers are getting really big, really fast, multiplication is probably the operation that you're using. Okay, so that's a brief introduction into inductive reasoning. In the next video, we'll do a few more slides from this notes presentation. It'll get a little bit tougher, but there's basically the same concept. So best of luck with this. If you have any questions, don't be afraid to reach out. Thank you.